Okay, welcome to day 11 of Advent of Code. And we will start, as usual, by looking back on what we learned from the previous day. So, what do we have here? I mean, on the whole, day 10 was, kind of slow, but also just kind of grubby code. Nothing we wrote was very pretty. It wasn't a particularly hard problem, and we just kind of mucked it out. It's worth pointing out we never got to talk about in day 9. I wrote this completely trivial Q class right here, and but I wrote as a class and not as a struct. And it's just worth mentioning that the main reason I did that is because it's all node based. And I haven't implemented a deep copy, and so it seemed like making it a class so that it has class copying semantics was very slightly less surprising than making it a struct and then having the lack of deep copy be a thing. So that's why I did that with the Q class that I used in day 9. But anyway, in day 10. One thing is, I didn't really think through my code structure, how everything was going to work before I started typing. That probably slows you down. It's probably not the right way to do programming contests. But on the other hand, there is something to be said for just kind of exploring and realizing, particularly if it's a more complex problem, which bits of logic you're going to have to build, because very often that will quickly show you what the really hard pieces are and what the more complicated data structures are and what you're going to want to try to find in your library. So there's nothing terribly wrong with just kind of writing little bits and pieces and plumbing them all together at the end, but it does usually end up with quite messy code, which is what we ended up with in day 10. There are actually ways to do parsing where the code doesn't look ugly. There were periods in my career where I did a fair amount of text parsing, and I ended up having various code structures that I was very comfortable with and felt natural and I thought were good looking and everything, and I would reuse the same structures in various places. I don't entirely remember what that stuff looks like, but there are certain domains where just having more experience, it will feel more natural. Not much more to say about it than that. Looking back at the code itself, I note that this closes dictionary, I could have actually used the keys in that instead of here, because now we have this kind of ugly duplication of data between this string literal and the closes thing, which is not a big deal because it's only 4 characters. But it would have been better to just put that stuff in one place, and the closes dictionary seems like the right place to do it. And then obviously you can extend your code by adding additional delimiters into the dictionary and nowhere else, right? So, although actually, no, we've explicitly listed them down in these, so, making it a dictionary from opening to tuples and is a thing you could do if you really wanted to make it extensible, but programming contests are not really about extensibility, so it is what it is. I just want to point out, I had forgotten one of these increments to pause, but I caught myself before I even ran the thing for the first time, and I just thought it was worth noting that I have so many times written code and forgotten to increment pause for the first run and ended up in infinite loop, literally dozens of times. I have written programs that did that. So now it's become a bit of a tick. Oh, and remember to increment the position thing. Yeah, okay. Our parser here is recursive because that's the easiest way if you have nested things. We all know you can't do that with regular expressions, but the easiest way to do kind of nested parentheses and things is with recursion. There is a problem with this in general if you are parsing untrusted input. then people can just blow your recursion depth by sending you a huge number of like open parentheses and things. Among the many things that can happen if you have a non-trivial parsing routine that you allow untrusted input into. So I guess the broader issue here is that parsing routines for untrusted input are like really hard to write, and JSON and YAML are terrific. Like they're some of the best things that our industry has come up with in the last 20 years. Not because they're complicated or brilliant, but because parsing is a genuinely hard problem. Just turning any old input into some structured internal representation, and so having parsing libraries that make that easy is a great thing. XML and its precursor SGML were kind of terrible because they were actually first of all, they were about marking up text and not structured data, and it turns out marked up text is not nearly as big a deal as structured data. But also they had really weird data models, whereas JSON has a very simple and straightforward data model. And simple and straightforward means it's very adaptable. So anyway, I'm a big fan of those. Anyone who's worked with me in the last 10, 15 years knows that I'm a big fan of JSON and YAML. So yet another reminder that I should actually read the problem because I didn't read part 2, and that was the source of this bug that I came up with. One thing, so I wrote this code trying to put a let statement and a conditional together inside an if. I couldn't figure out why it didn't work. Well, it's because the variables that you introduce with a let are not available in the same expression that the let appears in. But you can use a comma, which has the same semantics as and, I think. So if you wanted to do that, you can just use this comma syntax down below. And we could have used that instead of, where did we do it? Instead of here, we moved this test down from there because we couldn't figure out how to make it work. That's how you make it work, right? I also actually tried to do some debugging with Lldb, but I'm using a separately built library. And for whatever, I don't actually entirely understand the mechanics of why Lldb works this way, because I haven't sunk a lot of time into figuring it out. But it doesn't pass the dynamic library path through to the things you run. So if you want to run something that depends on a library, you actually have to launch it not with the run command, but with this weird invocation that passes along the environment variable. Maybe there is some more clever way to set up the environment variables, like when you invoke Lldb, but if you run Lldb with like the -o, the one-liner thing, and do that as your first line, then you can actually set this food variable using the environment variable. The trouble is, inside Lldb, you don't even have the environment variable, so you have to be able to cut and paste it from somewhere, and it's a pain. How much time do we have? 30 seconds. So we can just briefly touch on, so I used this new software last time, and I think the live stream worked. There were at least a handful of people who watched it, so that's a thing. I don't think I knew how to end the live stream correctly because I got a 20-second buffer, and I think when I hit end, I lost the last 20 seconds, which was a shame. And also, I am recording a higher quality local copy, and then I upload that to YouTube, but then I have 2 copies of the same thing, and I kind of need to figure out what to do about that. But anyway, we are moving on to day 11. Here we go. Come on. 3, 4, 5, 6, 7, 8, 9. Yeah. Okay. How many flashes? Okay, we can do this. Is that all? Okay. No, let's get rid of you. We need to be big enough that everyone can read. There we go. And we will pre-process all our input here, right? Turn it into integers, I mean. But it's a character, so we need to turn the character into a string, and then into an int. And then let's just make sure we've marshaled our input correctly. No. Print output. Wait, what? 1, 2, 1, 2. Okay, that's better. Yeah, that all seems reasonable. Okay. We need another neighbors function. I said last time I should have put this in a library. So, no, let's call it P. And this is going to be an array of length 2, again because tuples kind of suck. Bunch of things. Okay. So if greater than 0, then we'll do the lefts. You know what? I did this before, and I second-guessed myself a lot. This is fairly slow editing, I gotta say. I'd be better in Vim. It's not equal to P. Is that more elegant than last time? Yes. Is it very elegant? No. Oh. Okay, should we bother testing that? That'd be boring, wouldn't it? Okay. Ba-ba-da-ba-da, ba-ba-da-ba-da. First, the energy. Okay. Okay. In no. I don't know if I can do plus equals, can I? Why? No. What is it warning me about then? Immutable. Oh, it was never used. Oh, here we go. That makes more sense. Okay. Okay. Then anything greater than 9 flashes. And a flash increases all the neighbors. So So the point is, we're going to keep looping over everything until all the flashes stop, which is not super efficient, but it should be good enough, I think. Yeah, this is quite ugly using these arrays like this, isn't it? Data. And okay, and we have to remember who flashed so we can set them to 0. Ba, 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 ba. Okay, so that is everyone flashing, right? And then 4 in P1, P0 equals 0. Okay, now let's see if this compiles. It's very slow. Extremely slow. So why is that? We're doing this 100 times. Flashed is false. Oh, that's why, because it's infinitely long. Because we do have to say data. Y x equals. I think 0 is good enough. We just want to make sure things don't flash twice, right? Okay. And so what are we doing? Are we counting the number of flashes? There have been given the simulate 100. How many total flashes? Okay, so and it's how many times we do this. We've been way too slow to get a good time on this because it's quite a straightforward problem, I think. It's the next one that might be a little dicey because he's maybe gonna want to go some ridiculous number where we can't just brute force it. Let's see. Oh, I didn't get it right. Okay. There have been a total. So let's take his sample and see how we do on his sample. And 1557. That's not what he got, is it? 1656. Okay. Before. Step 1. Step 2. 6, 7, 8, 9. Okay. So after each, or before each step, no, after each step, let's print. What are we doing? Data dot L, is that what we want to do to get a visualization? Let's see how that. No. Parameter number 1. Oh, wait, hang on. What is this? Okay. And let's just do the first 5. Okay, so how are we doing here? After step 6.5 and then 3.7 looks good. 6.5 and then 3.7, and then it's totally wrong. 8, 6.5 after step 2. 9. So that went off, and that went off. But the neighbors were not incremented. So did we forget to increment our neighbors? I thought we wrote logic to that. Data, neighbors. I thought, well, okay. Plus equals 1. Flashes. Yeah. Is our neighbor's function all wrong? Oh, yeah. Neighbor's function. I need a clean way to write that neighbor's function. Well, now it's just totally wrong, isn't it? Okay, 6.537, 8.8, and 4.8 is looking good. And then 00509, 9,000 is looking good. 2263, 0211 is looking pretty good. 5532, yeah. And after step 5 is 44. Oh, because we only did 5, so of course we need to do 100. So does this get us? That was the right answer, wasn't it? 1656. 1656. Okay, so now we just switch over to our real data. So very slow solution for the first part today. Any debugging on a trivial problem and your time is going to be atrocious. How long have we taken? Almost 20 minutes just to do the first part. Ish. Okay. How much more machinery do we need to build? All octopuses flash. Ooh. Okay. So, if and I don't know if the answer is going to be t or t plus 1 here, right? And let's actually let's get rid of these stupid things. I wonder, how is that? Oh, because I only went up to 100. So let's, oh, so it happens a lot, doesn't it? So it might happen just at time. So 209. So the first one is 0, I think. So I think maybe 210. It seems too small to be correct answer, doesn't it? Well, okay, that's all it took. Okay, fair enough. So we solved day 11. We can just briefly recap our code here. The hardest part for me, as usual, was just writing a function that, given a x and y position, returns all of its neighbors. It's ugly and stupid, and I'm bad at it. I hate that function. And then we kind of go through the 3 steps outlined in the problem. We first go through everything and increment it. And then we keep track of whether we have flashed, and we keep similarly which octopuses have flashed, right? And then we go through every position, and if something is ready to flash, then we make sure to remember to do the loop again. And we remember that octopus flash, and we increment all of its neighbors, and we suppress it so that it doesn't flash. The actual number we use doesn't matter, and because everything can only have 8 neighbors, I guess setting it to 0 would be good enough. But whatever. And then we go through everything that did flash, and we down here we go through everything that did flash, and we reset it to 0. But if everything flashed, then we alert us that it happened. So anyway, so join me tomorrow to reflect on how today went and to solve the day 12 puzzles. I will see you then.